This video is about ways of visualizing different types of data. And what we want to do is to identify different kinds of variable types. If we look at the penguins data, you may not be able to see this. Under species, we see this thing that says FCT. That means species is a factor. And factor is often applied to variables that are used to categorize things into different groups. Similarly, island is a factor and sex is a factor. Bill length, what we see underneath that is DBL. And what that means is that it's a double precision number. It's a number with a decimal place, and uh, we treat it as a real number. This NA means data were not available for that particular record. Bill depth in millimeters is also a double precision number. And flipper length and body mass and year were all measured as integers, so no decimal points in those. So let's first take a look at univariate analysis. One of the important things about uh, one of the very useful things in doing analysis on variables is taking a look at the frequency distribution of them. So numerical ways of taking a look at that include histogram, box plot, density plot, and so on. So this is how we would go about constructing a histogram. The ggplot penguins, it gives us the blank slate. Then we set the x-axis by using aesthetics. We say geom histogram to turn it into a histogram. We can change the bin widths to make the graphic look a little bit better. It's likely that this is far too many bins. That looks much better. And then we give it some proper labels. So that gives us an idea of what the distribution of the weight in grams of, I guess, mass in grams of penguins look like based on the data that were collected. Box plot is another way of looking at those, at distributions. So we start off doing the same thing. We ask it to do with box plot. So what the box plot indicates is the median, the quartiles, and something that I believe is up to 2.5 times the interquartile distance. And it also will indicate outliers that are beyond that. We can flip it around so we can say that the body mass is on the x-axis instead of the y-axis. And this is where we said the body mass was on the y-axis in the previous one. Labels. We can start looking at density plots. We start off the same way. We can say that the body mass is on our x-axis, and we can put an approximation of the distribution using a smoothed line on that. Sometimes this is a better way of getting a general feeling for how a variable is distributed. Color sometimes helps. Uh, you can change things like line border widths. You can change the colors of the lines. You can change the alpha levels. So now we can actually see the grid lines behind the distribution. Remember, alpha refers to transparency. And you can take a look at this in a few different ways. So in this case, the distribution of the penguins is right skewed because the large tail is off to the right. It's pretty obvious here and here and also here because of the wider interquartile distance here than there, and also the length of the whiskers. And I would say that this distribution is unimodal. It looks like there is a mode here. This could be just noise. You can see that with the density plot, it's smoothed out. So I would argue that this is unimodal. Okay, what if we're dealing with two data, two variables? So that's bivariate analysis instead of univariate, as we were discussing before. So we're looking at the relationship between two variables. If we were looking with two numerical variables, scatterplot would be the best. Uh, if we're looking at numerical plus categorical, side-by-side blocks plots or violin plots can be useful. Categorical plus categorical stack bar plots can be useful. And you can use an aesthetic, for example, fills, colors, shapes, and so on, or facets to represent a third variable in any plot. Side-by-side box plots. So this is useful. What we're doing here is putting body mass on the x-axis, species on the y-axis, and we're doing a box plot. So what this gives us is a pretty good way of comparing the distributions of the three species of penguins that we've got. So Gentoo penguins have a median body mass quite a bit larger than the other two species. You can see a similar thing using density plots. So uh, in some instances, this might be a better way of representing things. This is just with lines separated by color. We can fill the plots, which could be helpful in some cases. But given that the way that these distributions overlap each other, perhaps what we want to do is specify an alpha level or a transparency level, which will allow us to see the entire distributions, even if they are overlapping. We can put a legend on the bottom or other places in the plot. Um, Here's something that I have never really used before, but I'm starting to see that it's helpful. Could be helpful. So what we see here is something that looks a little bit like a density plot, but it's shaped more like a violin or some some kind of instrument like that. So showing the same kind of information. Again, species on the x-axis, body mass on the y-axis. We're asking it to give us violin plots. Again, we can see how the distributions compare. We could look at the distribution of, or the actual data points within the plot. Um, these overlap so much that it's not terribly useful. But what we can do is add a jitter to the plots so that we can get an idea of the how the density of the individual data points shows up on our graph. And we can use some extra aesthetics to help us differentiate things on the graph. So here we're using coloring by species. Uh, we don't really need to have a legend because we know the species from the x-axis label. And if we wish to, we could use one of these scales that helps people with different kinds of color blindness. So I will stop there.